The topic that we are going to do, is basically chemical bonding. So the chemical bonding, is going to be divided into two. Which is going to be ionic bonding, which we have learned, previously. And today I am going to teach you about covalent bonding. But before we go into covalent bonding, I will do a revision, on ionic bonding. Now, for ionic bonding, we need to know that ionic bonding happens between metal and non-metal. Metal and non-metal. For example, if you have group 1, group 1, group 2, and group 3, they are metal. Metal and non-metal are going to be group 5, starting from group 5, group 6, and group 7. We are going to have ionic bonding. Now, what is going to happen? Because group is going to be defined by having the valence electron. So 1 valence electron, 2 valence electron, 3 valence electron, 5 valence electron, 6 valence electron, and 7 valence electron. So they are going to form positive 1 charge, positive 2 charge, positive 3 charge. Why? Because they will lose the electrons. And for this one, they are going to form negative 3, negative 2, and negative 1. Why? Because they are going to get 3 electrons, get 2 electrons, get 1 electron. So when they are going to have tendency, metal have tendency to lose electron. Non-metal have tendency to gain electron. So there is going to be what we call as transfer of electron. Example, if you have sodium, sodium is going to be from group 1. It's a group 1 metal. And group 1 metal, they will always form plus 1 ion, so Na+. And if you have an example of group 7, chlorine, Cl, they are going to be forming Cl-. But generally what happens, Na+ is formed because they release 1 electron. Cl- is formed because they have received 1 electron. And the similarity over here is these 2 electrons belongs to the same. It means that's the electron that is circulating over there. It means sodium is transferring the electrons to Cl, making it Na+ and Cl-. And there is a form of attraction, that will happen between Na+ and Cl-, what we call as electrostatic force of attraction. Electrostatic force of attraction between opposite ions. This is positive ion, negative ion. So this is what we call as ionic bonding, ionic bond. It's a bond between ion. And related to ion, you need to understand positive ion, which are going to be formed by metals, are also going to be known as cation or anion. Jensen? Cation or anion? Positive ion. Positive ion. Cation. Why? The T looks like positive. Cation is positive ion. Negative ion, is known as, they generally form by non-metal. So negative ion, you can remember anion. Negative ion. N stands for negative. You can memorize that way. Positive ion is cation, anion is going to be negative ion. And you are going to have this ionic bond. And generally we have learned, if I want to show, like for example, Na, if I just want to show the outermost electron, the shell, we know that this is 11, so it's 2, okay, 2, 8, 1, okay, 2, 8, 1. So the last electron is 1, okay, so you can actually draw, okay, last electron is going to actually go out, so this one no more, okay, so they will form Na plus, and you are going to receive that, okay, the Cl is going to be 17, so 287. This supposed to be 1, 2, 3, 4, 5, 6, 7. This one will come over here. They will form negative, okay, ion. And you can leave this as empty. Or let's say this one is given out, sir. This is now going to become my new outermost electron. You still can draw the 8. No issues. Okay, you can leave it empty or you can draw all. Okay, if you're drawing all, it means you're drawing this. If you're leaving empty, it means you are drawing this. Okay, both also accepted. So anyways, okay, now if I'm talking about ionic bonding, okay, with magnesium chloride. Okay, magnesium chloride, Mg, okay, Mg is 212, 282, group 2. And then chloride, okay, so Cl17287. It means that Mg will form Mg2 plus. Okay, this one will form negative 1. So now, if I have Mg, okay, I generally have 2 electrons. Okay, so when these 2 electrons goes out, I put the standby 2 electrons outside. And then this is going to be 2 plus. Okay. And then I have Cl. Cl, 1, 2, 3, 4, 5, 6, 7. Cl can only accept 1 electron. So 1 came here. This will form minus. But it's not solved yet, because there's another one more. So you bring another Cl, 1, 2, 3, 4, 5, 6, 7. Bring this, put it here, close the bracket, minus, and this is the reason why we have MgCl2. Okay, because you need 2 Cl. And the best way to look at it is quite simple, okay, because you can have, let's say for example, calcium, and then I have Cl. Let's say O, I give you some example, and A, K, and I give you other examples, maybe Br, okay, group 6, 7, group 5. 5 is, so okay lah, whatever, yeah, let's actually try with whatever we have, yeah. Now, if you have all this, okay, the first thing, okay, is calcium is going to be group 2, okay. They are going to form Ca2 plus, okay. Sodium is group 1. How do I know all this? Is all from the periodic table. So this is Na plus, group 1 also, K plus, group 2, Mg2 plus. Yes, yeah, all the periodic table will be given up to Jc2. Okay, now Cl is group 7, so Cl minus, group 6, so 2 minus. This is group 7. Okay, let's try NaO. Okay, Na, NO, Na plus, 2 minus. Okay, so you look at this value over here, 2 minus, this is only plus. So this one needs to times by 2. You have to make it into 2 plus. And now it will become 2 atoms of Na. The one that you times Br2. Okay, let me circle this. Okay, the one that you times. If you are not sure, okay, we can actually, you see here, Na plus, oxygen is receiving 2 electrons. Receiving 2 electrons. Sodium can only give you 1 electron. So 1 electron from 1 sodium. Where is another electron will come from? From another sodium. Then only these 2 electrons will be going into this oxygen. So that is, if you don't understand that, then you remember that way. But if you are okay with that already, you just need to times by 2. Make it plus 2. And you write down this is 2 Na2O. And what is the name for this? This is sodium. The positive ion, no issues, sodium. This is no longer oxygen, now is oxide, sodium oxide. So, all these ion, what is the name? Chloride, oxide, bromide. If I have I, tell me what might be this name? Iodide, yeah, correct. Iodide. Okay, so this is quite simple. But remember last week I told you to go and memorize something more complicated about this, okay, which is I told you to memorize, okay, on the following ions. This one cannot be obtained from your periodic table, so you have to memorize. Okay? OH minus, SO4 2 minus, NO3 minus, SO3 2 minus, NH4 plus. 1, 2, 3, 4, 5. One more. What did I miss? Carbonate. Okay, good. CO3 2 minus. All these, okay, are the ions that I told you to memorize. And the name of this ion, okay, is going to be hydroxide. Okay, hydroxide. This is sulfate. Something like Dr. Fate. Sulfate. This is sulfite. Okay. This is nitrate. This is ammonium. And this is carbonate. And this one have to memorize. Okay, have to memorize. Now, let's bring those stuff here. Ca2 plus, Na plus, K plus. Let's bring in Mg2 plus. Let's also bring in Al3 plus. Okay, now you select one combination. Okay, Ca2 plus and SO4 2 minus. Okay, now Ca2 plus SO4 2 minus. You see, 2 plus 2 minus. No need to do anything. So it's going to be CaSO4. And what is the name? This is calcium. Okay, no change. No change, just sulfate. calcium sulfate. Simple. Okay. So you guys, okay, maybe I'll just ask, okay, maybe, why I forgot your names, yeah, Brian, yeah, yeah, Brian, select me one, okay, Al3 plus, okay, you want something tough, okay, which one, yeah, which one, sulfide, okay, SO3 2 minus, this is tough, okay, this is tough, so you see, 3 plus 2 minus. How are you going to make it same? Yeah, 3 plus and 2 minus. Okay, this one, okay, you need to find what is the common multiple. Okay, common multiple, okay, so which is 6. Okay, which is 6. Yeah, that is one of the way. Yeah, but don't simply switch for everything. Okay, the simplest common multiple, yeah. So this one, okay, you just times by 3, easier. Just 2 times 3, 3 times 2. Okay, so just switch, up to you. Okay, up to you. But circle this one first. And you are going to get negative 6 and positive 6 here. So Al is one element. So one element, you just put 2 there, no problem. This is not one element. There's sulfur, there's oxygen. You are going to times by 3. SO3 more than one element, put bracket, and then put 3. What is the name for this? Aluminium sulfide. Okay, let's try some more. Okay, Kimberly, absent. So, okay, Naomi, another one. Okay, Na plus. Okay, this is simple. Okay, Na plus CO3 2 minus, 2 minus plus. Okay, so you try to get plus 2. Okay, times by 2. So Na is one element. So you have Na and then CO3. So Na2, forgot. Yeah, Na2, CO3. And what is the name? This is sodium, just follow, carbonate. Is that okay? So you can take any of these combination, okay, and you can actually play around. Yeah, like I give you one more example. Okay, maybe another difficult one. Okay, maybe we try aluminium with maybe this, easy, and then maybe we try with this. Okay, so Al3 plus. Let's try with the easy one, and then the last is we are going to try with the difficult one. Okay, 3 plus minus, so times by 3. Okay, you want to get plus 3 and minus 3. Circle this. Al, this is more than one element. So bracket NO3 bracket 3. What is the name? Aluminium nitrate. Again? The nitrogen. Al, you look at the periodic table. Al is one element. This one, nitrogen, okay, is one element from the periodic table. Oxygen is one element from the periodic table. Okay? Like this one is one element, Al. This is one element, another element, 2 elements already. carbon and oxygen. If sodium, Na, it's not like two elements, Na, N, and then A is another element. No, Na is one element. Okay. Now, this is yes. Okay. If it is going to be one element, generally, the first letter is capital, the second letter is small. Sodium Na. Aluminium, A is capital, Al is small. Okay, something like that. You can remember it in that way. Like if you see over here, all of them are capital letters. So they are all different elements. This is one element, capital and small. Capital and small. Okay, so one element. So that will be another way that you want to memorize this. Okay, let's look at this 3 and 2. Okay, so times 2 times 3. Okay, if you want to crisscross also can. Okay, so times 2 times 3. So you are going to get 6 and -6. So this one, okay, rather than circling this, it's better to circle this. Al is one element, no need to bracket. So it's 2. CO3, this is put 3. More than one element. Okay, I hope this is clear. Okay. Now, let's move on to covalent compound. Okay, but before I move into covalent bonding, okay, one more thing that I almost forgot. Okay, transition elements. Okay, transition elements we have already learned. They have certain properties. One of the property is they can form colored compound. They can be used as catalysts as part of your project. Yeah, they can be used as catalysts. They have different oxidation number. Now, what is different oxidation number? I told you iron, okay, Fe is a transition metal, transition element. Fe can exist in Fe2+. Fe can also exist in Fe3+. There are two. So, when I write, I need to be very certain what am I referring to. Okay, it is very important to say, is it Fe2+ or are you talking about Fe3+? Another example is copper. Copper, we can have Cu+. We can also have Cu2+. Also transition element. So, to prevent confusion, we write, okay, let's say for example, all of them are oxide, for example, yeah. I'm going to join this with O2 minus. Okay. When I join them with O2 minus, okay, let's see what I can, how do I write them? You see, Fe2 plus and O2 minus, you join them together, same and same, you are going to get FeO. Now, because Fe is 2 plus, this is what we call as oxidation number. No, not yet. Okay. When I have these 2 plus, rather than saying this as iron oxide, because iron has two forms, you must mention that this is iron 2 plus, yeah. So bracket 2 oxide. That's the meaning. You must show the bracket 2 to show that it is Fe2 plus. Let's look at this. This one also, you see, when I want to make them together, you cannot simply join them together. This one must times by 3, circle. I must times this by 2. And I am going to write it as Fe2O3. What is the name? Iron. Don't look at this here and say this is iron 2. No. Iron 3 plus. So, 3 oxide. Okay? And we have, okay, like this, times by 2. This is copper plus 1. Yeah, so copper 1 oxide. This is copper 2 oxide. Copper 1 oxide is Cu2O. CuO. Okay, like what we did, just the naming. Okay. Now there are certain transition elements cannot form within the transition element. They cannot form multiple or many oxidation number. Example, zinc. Okay, zinc is an example of transition metal that has only one type of ion. They can only form zinc 2 plus. Okay, they can only form zinc 2 plus. Silver. Silver is Ag. They can only form Ag plus. So not all transition metals you need to give the Roman number in the middle. Okay, like zinc. It's okay to say zinc what? Zinc sulfate, zinc chloride. No need to put number. Why? Because zinc is always plus 2. Sodium chloride, you don't actually say sodium 1 something. No, no need. Because sodium is always plus 1. Okay, similar to that. Okay, only few compounds, okay, few elements in the transition elements you need to memorize. The one that I'm asking you to memorize are 2. Iron, and I ask you to memorize copper. I'm not asking you to memorize many things. Iron and copper. The rest you will learn as we learn. Okay? Iron and copper, you make sure there is a number over there. Okay, let's move on to covalent bonding. Any questions on this? Okay. Tomorrow we will have activity on this, yeah? Make sure you go through how to write the name and so on. Now, covalent bonding, okay, in simple way, we can just say it's the bonding between non-metal and non-metal. So non-metal and non-metal, okay, they are going to be from group 5, group 6, and group 7. Example, let's take from group 7, which is Cl. Now, Cl, okay, is going to be 17, so 287. How do I know it's 17? From your periodic table. And when I draw, okay, the electronic configuration, yeah, the outermost electron, okay, you will have something like this. You have 7. Okay. Now, I am going to draw another Cl. And I'm going to draw using dot. This is like, in order to go to the exam hall, you need to bring 8 pen, for example. You need 8 pen or pencil. But you only have 7. Another person also have only 7. So what they decide, oh, whenever Mr. Gopi asks how many pencil I have, I quickly borrow your pencil. You tell your friend, Mr. Gopi, I have 8. Okay. Then suddenly I go to your partner and ask, okay, how many pencil you have? You show your friend's pencil and say, I have 8. Okay lah. So this is sharing. Okay. How it works? They are going to overlap. Okay. So I will just draw like this. Cl, Cl. In order for this to work, okay, in order for this to work, if you need one, you must be also ready to share one. This is very important. If I need one pen, I must be ready on standby, one pen to be shared immediately to my partner, whenever my partner requires it. Okay, so here, I know that Cl has 7 valence electron, but I must be ready to share anytime. So, ready to share anytime. This Cl have 7 electron also. That electron must be ready to be shared over there also. If you want to borrow, you must stand by with one. You want to share, each of them must be standby. Okay, and this is going to be what we call as covalent bond. Okay, it's the bond. Okay, it's the bonding between, okay, the element, okay, and the shared electron. So this is called covalent bonding. And at one moment in time, you look over here. If you count, that's 8. We call it as octet structure. Octet means 8. Okay, 8 means it's a complete shell. Okay, octet structure. Octet, yeah. Octet structure, or we call it as noble gas configuration. What is noble gas configuration? All the 8 electrons are completely filled. Okay, so they have 8. If you look at this Cl, they have 8. So this is what we call as Cl2. This is an example of covalent compound. Okay, let's look at another type. This one is between oxygen and oxygen. Why? Oxygen is going to be 8, 2, 6. 6 valence electron. So if I have oxygen, okay, 6 valence electrons, so I draw 6 valence electron, yeah. 1, 2, 3, 4, 5, 6. 6 valence electron, 1, 2, 3, 4, 5, 6. Okay. Now, unlike the previous example, you do not require, oxygen do not require only 1 electron to reach the octet structure. Oxygen now require 2 electrons. And I told you, if you want to share 2 electrons, you must be ready to share your 2 electrons to other people. You set aside. Okay? So it means you require, oxygen require 2 electrons from outside, from another oxygen. They need to set it aside. Okay? So I draw over here. They will overlap. Oxygen, oxygen. They need to set aside 2 electrons. I set aside 2 electrons because I want to share with the others. I have 6, so here will be 4 electrons only. Okay. Here, 6 electrons, I must make sure I set aside another 2 electrons for bonding. And I have 4 electrons outside. In total now, you count. 1, 2, 3, 4, 5, 6, 7, 8. Octet structure. Good. Then I go and check this particular person, oxygen. 1, 2, 3, 4, 5, 6, 7, 8. Good. Octet structure. So this is what we call as oxygen. Oxygen is also going to be a covalent compound. But what is the difference over here? The difference is you have one pair, okay, of bonding. One pair of electron involved in bonding. So when I draw, I represent like this, Cl, one pair with another Cl. So that line represents one pair of electron. But for oxygen, how many pair of electron are there? Two. So when I draw oxygen and oxygen, I put two lines. One line is one pair, another pair. So this is called single bonding, single covalent bonding. This is called double covalent bonding. Of course, we want to see triple covalent bonding. Okay, let's see triple covalent bonding, how it looks. So triple covalent bonding, example, nitrogen, N2. Now N2, okay, nitrogen is going to be 7, so 2, 5. 5 valence electron. In order to reach the octet structure, 5 valence electron, they must get 3 more electrons. Okay, so it means that nitrogen, okay, if I just simply see that nitrogen, okay, 1, 2, 3, 4, 5. Just simply see that nitrogen 1, 2, 3, 4, 5. So now they require 3 electrons. Okay, if you want to share 3 electrons, you must set aside your own 3 electrons. Okay, if you want 3 electrons from someone else, you set aside the 3 electrons. So now, nitrogen overlap with the nitrogen. This nitrogen set aside the 3 electrons. Okay, let's say I start with the X. 1, 2, 3. 3 electrons already set aside, so there's only another 2 electrons. So I put the 2 electron here. 3 electrons set aside. So dot, dot, dot. Okay. And 1, 2, 3 already set aside. There's only 2. So I put over here. This is going to be for nitrogen. Now for nitrogen, because there are going to be 3 pair of electrons, 1 pair, 2 pair, 3 pair, this is going to be triple bond over here. This is called triple covalent bond. So single covalent bond, double covalent bond, and triple covalent bond, CH4. Okay, why? First of all, this is non-metal. Okay, non-metal. Hydrogen is considered to be non-metal as well. They are not metal, yeah. Just because they have 1 electron doesn't mean they are group 1. They are set separately. CH4 is an example of covalent compound. And carbon, okay, carbon is going to be 6, so 2, 4. They have 4 valence electron. Hydrogen, they have only 1 valence electron, okay, they need 1. So now you see here, carbon have 4. So I just put 1, 2, 3, 4. Hydrogen needs 1, but carbon needs 4. So what they do? They share with 1 hydrogen. Each one, carbon will give 1, hydrogen give 1. Okay? Not enough. Look for another hydrogen. Carbon will give 1, okay, hydrogen will give 1. For hydrogen already settled, but for carbon it's not settled because it will be only settled when they reach octet, which is the 8 electrons. So you see 1, 2, 3, 4, 5, 6 only. You go and look for another hydrogen. Share. Okay? Look for another hydrogen. Carbon put for sharing, hydrogen share. Now, this is called CH4. And you can see, for hydrogen alone, 2. Hydrogen alone 2. Hydrogen will not follow octet. Why? Hydrogen, you see, the first shell must be always 2. Then followed by 8, 8, and so on. So hydrogen is 1. So to complete the first shell, you just need another one more electron only. Okay, this we call duplet. Okay, not octet. Okay, but just remember hydrogen just require 2. Once you get this, for carbon, you count 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8, done. So this is the explanation for group 4. Okay, group 4 will be special. Okay. I think this is my lesson for today. Yeah. Of course, there are more to it. Okay, more to it for the covalent compound. Okay, we will try some examples, but the basic stuff is there. We will try more examples like this next week.